Hi everyone. I am Bruno. I am a software architect for LM Solutions, and I am going to share you the experience I had in my previous employment, where basically a startup in the GNSS technology, which is literally geolocation, satellite geolocation technology, decided to pick up Elixir with no previous experience to create an IoT solution from scratch. And small recap, I'm working actually for an solution. The previous job was the one that I am going to talk to you about. And in my previous life, I had some experience with other languages and also other industries, mobile gaming, digital asset management, fintech, IoT, which is the one that I'm going to talk to you about. So the title basically wants to, lots of people told me it's a very cryptic and enigmatic title because, and I told them that it was basically because I wanted to tell how another version would have been from zero to hero. But since we're going through the stars, because we're talking about satellites, this was, in my opinion, a nicer title. Bit of context. Albora Technology is a company that has been founded in UK in 2017. For the records, the job was done in Barcelona. The development team was in Barcelona. Part of the development team was in Barcelona, where at the time I was living. They have been awarded with an H2020 grant from European Commission, and basically their business case was based around Alcor, which is a proprietary solution that they have created in order to enable GPS geolocation in scenarios where it is totally impossible to geolocate whatever asset, whatever dimension, whatever kind of asset. And what was the objective of the project? We started with the idea to create a complete end-to-end proof of concept of the architecture. Now, you imagine the architecture as something like multiple types of assets ingesting data in our cloud architecture. And on the other side of the pipe, there's literally the customers that have basically an application that gives them the chance to track in real time their assets and get a bunch of statistics and a bunch of data about the assets. In terms of the dimension, consider that on average the system should be working on the long term with at least, this is a conservative estimate, 100,000 devices sending information once per second. What about the amount of information? Consider that a single payload can be up to 5 megabytes because they, as you can understand, I cannot undisclose so much about the technological aspects of the project, but consider that the algorithm is based on one side, the use of a very rich set of data. On the other side, the aggregation of several data sources to provide the output. So we were talking ideally of an architecture able to crunch a massive amount of data in total real time. So Albora Technologies being the company, what about the team composition and skills? I told you that they were in Barcelona, the development team, but there was also a pretty big team here in UK about the device side of things. Basically, Albora is also working on some specific devices to do this. The R&D team was really a massively skilled bunch of developers. They were all PhDs in this GNSS technology. GNSS stands for Global Navigation Satellite System. It is basically the model, the theoretical model that we know implemented in technology like GPS, which is the American version, Galileo, which is the European one. Then there are a bunch of others, Chinese one, Russian one, they're called Beidou, GLONASS. There are lots of these implementation. In terms of the development team, it was literally to be assembled. I was contacted by the team lead, which was a man with a pretty long career behind him. He had big experience in commercial software, and he had solid experience in Java Scala, and he knew a bit of Erlang. So I saw a good chance to talk about Elixir there. But definitely there was no absolutely knowledge or confidence with Elixir at all. What were the options on the table? In the discussion, we literally talked about C++, Python, and Java. Of course, C++ in terms of performance is still the best. Also importantly, we're talking about embedded devices, so there was some code which was ideally also reused between devices and the architecture if C++ would have been the language of choice. But there was, of course, other challenges in terms of development, in project management, and also deployment. About Python, it is definitely the language of choice to implement prototypes. And for example, the R&D guys were using Python to develop the prototypes of the algorithm. In terms of performances, it's not exactly the same, also because the environment for us was very critical in terms of concurrency. This is the reason for which I was so happy to see Erlang mentioned during our meeting. But definitely in terms of performances, it was probably not the best choice. Java Scala, well, definitely battle tested, but we saw a bunch of not really convenient things. For example, what you can read here, not the best choice in terms of concurrent programming. It's clearly not because Java or Scala are not very good at concurrent programming. But in my mind, my baseline was the advantage of having the OTP layer usable in Elixir, and we know what that means. We know how it's basically doing things easier to have the chance to rely on it in terms of concurrent programming. So these were the tools, but how would have been chosen for something? We definitely wanted to focus on business logic. We didn't want to spend time on having to spend nights to deliver a specific technology, which is good, but is a mess to deploy, for example. We didn't want to fight with technology. A good tool, in our opinion, would have been about being quickly able to deliver something, not fight to make things work. The deployment, our idea of deployment was to have something simple, because apart from the data sides point of view, which were definitely massive, it was still just a data pipeline, not something really, edge cases or things like that. So a complex deployment procedure in our idea would have been a very critical red flag. And of course, we needed scalability and fault tolerance. Scalability is pretty obvious, and fault tolerance also because with such a frequent data ingestion, we definitely wanted a platform able to fail and recover nicely without any intervention from the outside. So literally, we were, collecting all the... at this point, we were in a situation where we did clear analysis of the situation. And so the team lead decided to allocate 15 days to give Elixir a try. Now, why 15? In my opinion, 15 was a random number of days. Why not 14 or 20? The point is that I knew what we wanted to test for this attempt, let's say, and yet they were absolutely enough. And in fact, we have deployed the first microservice in 10 days, and nicely, it never changed over like 11 months. It was a service that was fetching on a schedule, probably once per hour, was fetching a FTP data sources. The files, there are a bunch of data sources, FTP data sources that NASA and other research companies used to publish all the information, the public information about 32 geolocation satellites that are in every moment orbiting the Earth. They are text files that literally can be downloaded and used. So we created this microservice which was able to fetch this, and in the orange rectangle that you can see, there was literally a MapReduce pipeline that gave us the chance to aggregate in a more convenient way the information and store in the data store layer to use it. This was the first microservices done in 10 days and was basically in a shape which was so good, so it was never been changed. Sorry. One more thing to tell, which is very relevant here, is that also just these 10 days were enabled to give all the guys that were jumping on this new technology, which was Elixir. This gave the developers a very good overview of the end-to-end process to deliver software with Elixir. And the constant that we made over all the experience, it was that there was really almost no friction in the process of translating our ideas to the software, which is basically the thing I think is most valuable to share. In terms of architecture, as you can see, it is pretty easy. We will go a little deeper in the architecture in the next slides. Basically, we have several types of data sources that are ingesting different types of data. That can be push or pull, that could be WebSockets. So we will see that. I have a slide for the input layer. This information got fed into the pipeline, which is a multi-stage pipeline, which in the end creates a data store entry for each of the assets that the user can interact with over what was at the time a React app. I don't know if it's been changed now, but it was a React application. The data sources, like I've told you, were push and pull using REST and WebSockets, or HTTP and FTP. The interesting thing was that in a given amount of time, I count, to the best of my memory, I count 6 different data sources. And the interesting thing about the pipeline execution was that in a given moment, if there was an information ready for all of the data sources, the pipeline execution was triggered. So it was literally all driven by the ingested data. Now the pipeline. Clearly, this is where the Altcore engine implements the logic and the business value. You can imagine the Altcore implementation is a very CPU bound calculation. It's a really scientific calculation. We're talking about fast Fourier transformations. We had dependencies like BLAS, LAPAC. It was really intense in terms of calculation. The stages that you see here were literally taking care of parts of this algorithm, which were executed sequentially. All of them, each of them was implemented as a microservice. We did this because we knew that in future, each of these paths could have been refined both in terms of architecture and in terms of performances. Interestingly, in terms of performances, we did this remembering that we could basically make nice things like using Rust, for example, to nif in code and achieve way better performances. Also, these stages had also the chance to fetch even more specific data from data sources to refine the algorithm and the data ingested to basically to have a better convergence in the output values. So we have seen the way we chose the language, and we have seen what we were supposed to do. At this point, what were the team challenges? Well, long story short was about getting the developers into commercial software development. Which can be pretty obvious, but you know, when your job is about making real research, pure research, where you have to have hypotheses and you have to create algorithms that verify the hypothesis, you really don't have to deal about test-driven developments. You're not probably never writing tests. It's really out of the scope of your work. But we were definitely in a situation where we needed to take this research to something usable for the final user. Definitely not a production product, but still something that was supposed to be used from different people. So there was a challenge to inject, you know, in the behavior the best practices that we deal with on a daily basis: continuous deployment, test-driven development, the approach to a structured deployment strategy, the usual for commercial software developers, everything that can be told as usual behaviors. It was very nice to see that basically all the developers saw during the development was very nicely, I wouldn't say accepted, but really adopted, because they were perceiving that as effective. So they started having tests first, which is really a massive achievement, to be honest. Not always we end up doing that. CI required over a given percentage. I'm mentioning the number, but just you know, as a rule of thumb, the number per se can be very debated. It's only about expressing how they really found the good way of doing these kind of things. And really interesting, they enjoyed functional languages, because apart from the scientific algorithms that we had to rewrite in Elixir, and probably it was exactly not the best choice in terms of performances, but for all the rest, they really you know, jumped on the wagon, meaning feeling that it was way easier to express concepts. And this is basically what I mean when I tell that really there was no friction in this transition, you know, taking some people from a specific way of developing software to another that could be considered, reasonable, considered being far from their usual things. Sorry. And of course, there was something breaking the harmony. You have seen here that we had these microservices. They were all made in sorry. Yeah, they were all made in Elixir except for the second one. The second one was a massive algorithm that was probably using all the scientific code that we had into our dependencies. Like I told you, BLAST, LAPAC, fast Fourier transformation. And it was really, it was big and was not reasonable to write it from scratch. Probably, basically, it was impossible to write from scratch if you were not really deeply into that specific problem and solution. So we decided not to rewrite it, but we instead wrapped the existing code, which was already existing. The C++ algorithm was already in place. We decided to wrap in a C++ microservice and deploy. It took probably 3 times the time of the longest time needed to create Elixir microservices. Was very slow from a point of view of debugging, and we got 2 bugs, one of them being about a copy constructor behavior in C++, which took like probably 3 weeks just to debug one bug. So this is probably obvious if we consider what is really C++ development, mostly in the web, because don't forget that we're talking about some sort of web development, in C++. But definitely was, I'd say, it was something totally different from all the rest that we were doing. And yeah, so we deployed this microservice, was the second one. What we did instead with the others was to basically start rewriting small parts of this code, of the most critical parts of the code, using Rust. Now, we had no specific, no previous real knowledge of Rust. Some of us were playing with it, but really as side projects. We knew about NIFs. There was some good articles, and there was also a bunch of good articles of using Rust for the sake of performances into Elixir software. And so we started using this in very, very small parts of the code. For example, when we had to manipulate some data very quickly in memory, or probably we had one library which was specifically written in Rust that we nifted in. And this is a relevant point, because I told you before that we were writing scientific code. That the whole application was really about taking a scientific algorithm and putting in the cloud. Definitely, functional language is probably not the best choice, but we knew that with technology like Rust, like NIFs, and in a language like Rust, we could postpone the need to face performances. Don't forget that this was still a proof of concept. And so in the end, the nice thing was that when we started niffing in this code, it was basically nice to see that it pretty nicely fitted into our development and deployment process. We basically created the module, we injected in the AWS Fargate clearly artifact was totally unaffected. So it was taking something totally different, gluing in and working and using. So it was really these kind of things helped also raising the confidence of the people in the language itself, because as you can understand, the most important the big guy that was under the light was Elixir there, because it was totally brand new for the company. They were, when you do such a big bet of adopting a brand new technology in a startup where definitely resources are not unlimited, so you have to optimize literally all of the stages of the pipeline. Having step by step lots of confirmations of the quality of the choice that we did was really helping in creating a very relaxed environment, having really a nice experience with a brand new technology. So I think that this is everything. Takeaways from this talk, and basically the reasons for which I wanted to share this project, this experience more than a project. I think that, well, provided there is a common background, common proper background, all the people I worked with had a computer science background, Elixir required a small mindset shift about functional paradigm, of course, and a bit of mentoring. It really didn't take too much to see people being basically able to go from the idea to the deliverable. Also, I think it's pretty important to say that they were getting fun. People were happy to experience a very small distance between the theory and the chance to write code and see things working. This to me, in terms of let's say team building, but the quality of the environment that you're working on, no frustration, happiness, chance to deliver quickly. It's really something that should be achieved most of the times, if possible. Low reaction times to change requests. With a properly written code base, I also saw these, let's say, junior Elixir developers being able to react very quickly to change requests in a context where things were pretty complex, because if you want to imagine the code, imagine code that is basically making scientific operation. It was not that easy to read that kind of code and to follow up, all the algorithms and things. But still, we were able to grant low reaction times when things were changing. And if you evaluate this from the point of view of a company, this is super important things. On average, the last point is something that I really think being true, and probably is the most important argument for a company. I think that Elixir can make companies save money because it gives you the chance to focus on the real things. Everything that it is designed to do is done in a really intelligent and smart way. So it gives you the chance to save the resources, not specifically money, but you can save time. You can save the time of your developers. You can save numbers of developers needed to work on a project. And in the very end, for a company, is money. And most importantly, if you're talking about startups, this is a very, very important argument that we should always put on the table when talking about Elixir and try to make it appreciate for its qualities. And I am done now. If there are any questions, Martin.
Indeed, there are. We have one question from Heiko Goes. If you want to unmute yourself and ask the question. Otherwise,
Yeah, I do. Yeah, can you hear me?
Yes, I can.
Loud and clear.
Yeah, I'm in the same position as you were. We start a new team and nobody knows about Elixir.
Nice.
And yeah,
and I don't know.
So and there's a problem. Really, a problem with this mindset shift. And I would like to ask you, what did you do to help your people doing this mind shift?
Yeah, you are right. There was a statement which was hiding lots of consideration. While it is true that I was working with people that had no knowledge of the software, like we are intending, as developers of real commercial software, dealing with customers, dealing with effectiveness, they were still PhDs that were really, really used to learn and do. So from that point of view, also a bunch of them were very had some experience in in Java and also in technologies like MapReduce and things like that. So somehow to them, the functional approach was really, really natural to achieve. There is one thing that I was asked during an interview right before this conference, and it was about the good things of Elixir. The guys, probably the biggest thing that they have done in common, they have read the Elixir documentation, which I spent a few words on that because you know, mostly in open source, it's all about, okay, you have the documentation, take it and use it. No, it's not always like that. But in Elixir, in my opinion, we have one of the best documentations that we can ever have. Of course, if you are dealing with edge cases, sometimes or most of the times you don't have relevant examples for your problems. But in my case, I saw the mind shift execution being emergent. I mean, they understood the language and the design and the idea behind the language, and they really jumped on it. And since I don't think it was a miracle, I see a contingency on things there. The design of the language, well, maybe some mentoring from my side, but you know, it's most about the real value of the language and the things. So if I should imagine a challenging mind shift, probably I would suggest a different learning curve made of comparisons between equivalent parts of whatever paradigm, imperative, object-oriented, and functional, trying to make the convenience of the functional paradigm emerge. Of course, this is not always true. This is not always a valid argument. But for general purpose code, I am strongly, you know, I jumped on Elixir after 16 years of development. So on functional languages first, and then on Elixir, exactly because of that.
It's always a fun, like when you think about how long a system will be in production, and sometimes the unwillingness from a stakeholder to perhaps spend 2 sprints trying to explore some new technology instead of like I think there's an argument you can make there where like if this software is going to be running for 3 years, couldn't we take 2 sprints trying out this Elixir thing, for instance, if you had that problem? I don't know. Anyone has any questions in Hoover? I know I forgot to ask you to place your questions in Hoover, but
let me add one thing about what you were telling, Martin, because it's a very interesting point. Definitely, from the point of view of good common sense, it is definitely doable. In my specific case, there was the experience of the team lead that was assembling the team that helped a lot, because definitely he knew how this world works, and he was super aware of the fact that picking up the right tool would have changed hugely the experience. And so the time spent, which were really 10 days, not much, it's literally a sprint, was really pure gold. Probably we could have been also taking 1 month because we were really on the same page. Sadly, that not always happens. You know, one of the hardest skills to find in people is the vision. You know, not today, but tomorrow and the day after and the day after. But yeah, that's there are the kind of small efforts that can drastically change the work experience.
Indeed. Depending on how open-minded people are, I think the terms in psychology is agreeableness and like to adopt a new language just to solve this problem that we, of course, already know how to solve in, say, C# or Java. Yeah, because it will take some investment. It's perhaps a couple of months, and then you're fluent in Elixir.
Yeah,
and
true.
you have gained so much.
True.
But I guess that's just two Erlang solution guys talking.
There's another question.
Question.
Go ahead.
Yeah, another question comes to my mind because many people in our company are used to strong type languages, and Elixir is a dynamic language. I don't know, did you do anything like type checking also, or what was your...
Good point. Good point. I have seen and I see this argument coming up every now and then. It is really one of the most important arguments about Elixir and dynamic typing. In that specific project, we weren't putting too much the finger towards that because we knew that ideally we would have been dealing with that in other domains like Rust or things like that in the final ideal version of the software. So we had no really big attention on this in the project. Definitely having the need of a strong typing can be a game changer there. Definitely, if you need that. Of course, we were adopting all the best practices. We were dialyzing the code and everything like that, which is still a way to achieve some part of that. It's not exactly the real answer to that. Yeah.
I think this is something WhatsApp is also trying to solve. At least there was a conference about a talk about it at the BeamConf